In this video, I'm going to work through an example calculation for our water in a Hydrate Lab. These calculations weren't too tough, but I just want to introduce the idea of lab videos this semester to help you with the pre-lab and the post-lab calculations. So you can see that I've got two trials worth of data here. And before we do any calculations, I just want to talk about the data that I've shown here. At the top of the data table, you can see that I've filled in the chemical formula of my salt, its molar mass, and then the ratio of water to salt. Do note that you need to get that chemical formula from the bottle. So if you did not write that down in the lab, make sure you get that information because that's going to be different for each group, and we want to make sure that you have the right information to compare to. Again, I have two trials worth of data here. You can see trial 1 on the left that I've shown in blue, and trial 2 on the right that I've shown in white. You might only have one trial worth of data for your lab, and that is okay. One trial is going to be enough to do the analysis. But I want to draw your attention to the data points at rows C and D. Notice that in trial 1, those two masses after heating were practically the same. And in trial 2, I saw a decrease in mass from the second round of heating to the third round of heating. We do want those two masses to be really, really close to each other. In the lab manual, it says we want them within 0.02 grams of each other, because that's how we verify that we've gotten rid of all the water. So you can see in trial 1, those are good data. Trial 2, this is kind of indicating that I did not get rid of all the water in my salt. As I do the calculations here, I'm just going to work down the table and just going to fill in row E, F, and then G, and just kind of go through the calculations as they're presented. So row E has me calculate the mass of salt that I initially heated. So I do that from row B minus row A. In my case, it comes out to 2.03 grams. So we'll go ahead and fill that in. Row F has me calculate the mass of the anhydrous salt. So that's row D minus row A. In my case, comes out to 1.22 grams. So we'll go ahead and fill that in. Row G has me calculate the difference between these two masses, which we are assuming is the mass of water lost. So in my case, it comes out to 0.81 grams. And a big assumption that we have in this lab is that any difference between the masses in row E and row F, we are assuming that that is water lost in the dehydration process. So 0.81 grams of water there. To write our chemical formula, we do need to put these quantities in moles. So we're going to do a couple mole conversions. So I'm going to take the 1.22 grams, that's the mass of my anhydrous salt, and divide that by the molar mass of the anhydrous salt that I calculated before we did the lab. So that's just a grams to moles conversion. We've done lots of those. And in my case, it comes out to 0.00764 moles of magnesium sulfate. We're going to do the same thing with our mass of water. So we're going to take that quantity from row G, 0.81 grams of water, divide it by the molar mass of water, which is about 18.015, and we'll get our moles of water, 0.04496 moles, according to my data. Okay, to round it out in row J, we're going to do the ratio between these two molar amounts. We're going to do the moles of water on top, and then the moles of anhydrous salt on the bottom. And in my case, it comes out to 5.882. And notice through all of my data here that I am kind of rounding for sig figs through the whole process. Once we have that calculated or measured mole ratio, we can do our percent error. So our measured value is what we get in row J. So in my case, that's 5.882. And then the accepted value is what comes from the label, the bottle. So again, in my case, this is a pentahydrate, so that is 5. So we plug those numbers in, and in my case, I've come out about 17.64% error. And again, I'm kind of rounding for sig figs here. I had about 4 sig figs in my calculated mole ratio, and so I'm just going to keep 4 sig figs in my percent error as well. Now, I'd say that 17.64% error is quite high for this lab. Generally, we see percent errors less than 10. So again, here's my calculated and the actual mole ratio that came out of that. And so I want to take just a minute and think about why that calculated ratio was greater than 5. So again, the big assumption that we're making in this lab is that any mass lost, we are assuming is water. Now we can't verify that, so that's just an assumption that we have according to the procedure and according to our data collection. Therefore, we should kind of think about this question as what caused my sample to lose more mass than it was supposed to. And so the first thing that comes to mind is spillage, right? So we're definitely losing water out of that sample, but what if I also spilled some of the sample through my handling? Again, that would show up in my data table as water. Now, of course, measuring the mass has its own error associated with it, but I think 18% error here is pretty big. So maybe something like the crucible wasn't cooled, and that messed with the measurement of the scale. We talked about how the air current can mess with the measurement. Maybe the data were really good and I just wrote something down wrong. Maybe a number got transposed or something like that. And that's showing up as a large percent error in my data table. And then the other thing that comes to mind is maybe the salt itself decomposed. So not only did we boil the water away, but maybe, something like a carbonate decomposed into carbon dioxide. That caused it to lose a little bit more mass. And then again, the big assumption that we make here is that any mass lost is water. And we don't have a way to differentiate between what actually was water that boiled away and what actually was some other source of mass lost. Now, if your calculated ratio came out to be less than the actual ratio, then you can kind of think about some factors that would cause you to not have lost as much mass as you were supposed to. I hope that was helpful. Thanks for watching.